All right, folks, this is going to be part 2.1, day 2. And we just kind of sheared this in half because it was a lot of information for one day. So we're still talking about functions, but now we're going to talk specifically about linear functions. And what it means to be linear is basically that you form a line. And I'm writing on this blank part because I just want to go back over some things that I don't think it's safe to just assume everybody remembers, because we're in a pandemic. It's been a long time and you're coming here after geometry, so you haven't really touched on this algebra for a while. So let's think back. A linear equation is going to form a line, and the line is going to either go up with a positive slope, it's going to come down from left to right with a negative slope, it's going to go horizontally with a zero slope, or it's going to go vertically with what we call undefined slope. And I always tell everyone to think of it like your roof, because your roof can go up, that's fine. Your roof can slope down, that's fine. Your roof can go flat, which is totally fine, but your roof cannot go straight up and down. That's like weird and undefined. Same with slope. One of the most common forms of the equation we use is called the slope-intercept form, which shockingly shows you the slope and the y-intercept, thus the name. So you have this living in your brain somewhere. You just need to bring this back into the front of your brain. That's called slope-intercept form, where this is telling you a few things. This is like your start value. So what's going on when x is 0, like at the beginning? When you go to graph, this is going to be where it crosses the y-axis. We call that the y-intercept, so we sound fancy. So that's going to be kind of your starting point when you go to graph. All right, how about this? This is our slope. We talk about slope all the time. It's like our favorite thing to talk about, and it's represented with an m, which makes 0 sense, but I didn't invent that part. So like we talked about up here, it can be positive or it can be negative, and then you're always going over to the right, so up and over, down and over, straight across. That is representing what we call the rise over the run, which is the change in y over the change in x. That little triangle means delta or change. That's going to make you super cool in calculus, because you'll be like, yeah, I already know what that means. So the change in y over change in x, you will remember somewhere deep in the dark crevices of your mind that this is our formula. So when we have 2 points on a line, we creatively call them x1, y1. And then another point we call x2, y2. And then when we connect those buggers, we can find the slope by calculating the change in y, which is found by subtracting our y values, over the change in x, and that's going to help us get our slope. So those are kind of things to remember about slope in general, how we find it, and so on. Keeping in mind, horizontal and vertical lines tend to be the ones that give people trouble. When you do a horizontal line, what I always say is you can see the axes that it will cross in the equation. So a slanty line, these are oblique lines, meaning the slanted ones. Oblique lines cross both, so you see both x and y. If you envision a horizontal line in an XY graph paper, a horizontal line is only going to cross the y-axis. So its equation is going to be y equals a number. This is going to be the axis where it crosses, and this is going to tell you where. So if it crosses at 2, then it would be y equals 2. And the rise of this is 0. There is no rise. So I would end up with a slope of 0 over a number, which means I'll have a slope of 0. So tie those together in your brain. A horizontal line has 0 slope and will only have y in its equation. So then similarly, if we take a look at a vertical line, the other exception to the rule, you don't represent horizontal and vertical lines in this mx plus b form because they're not oblique, and that's an oblique line form. So with vertical, if you try to envision what that's going to look like, if you draw in a vertical line, the only axis that's going to cross is x. And so it will be x equals a number for an equation. No y in the equation because it never crosses y. And again, if this crossed at 2, for example, or even 1, then my equation would be x equals 1. So it's telling you, again, which axes it's going to cross and where. And here, if I try to do rise over run, it has a really steep rise because it goes straight up, but there is no run. So when I try to do this, I'll get a number over 0. And if you do that on your calculator, that's going to give you an error. You can't divide by 0. So that's a reminder that our slope for this type of line is undefined. Blah. Okay, so that's kind of our background information, getting ourselves sort of in gear to learn what we have to learn today. So let's pretend we all remembered that this fun thing is really our new fancy way of writing y, because when you get to calculus, we call it function notation. This is no different than the y. So like if I had a point where I had plugged in an x and I got out a y, I can now think of that as the x is my x and the y is what we call the f of x. So when you see that f of x notation, it's really not going to be any different than a y. Okay, so in this equation, we already talked about this, so we'll hustle through here. Slope is our m, y-intercept is our b, independent variable is our x, and the dependent variable is y simply because it depends on what you pick for x. And then our ordered pair is just x, y. So general linear functions, that's just going to mean, like we talked about before, it might slope up, might slope down. You might have a horizontal line, possibly a vertical line. Those are all just kind of general equations. These two will have y equals mx plus b. This only crosses y, so that'll be y equals a number. That's horizontal. And my vertical line here only crosses the x-axis, so it will only have x equals in its equation. So just kind of start keeping straight. This is the one that we utilize the most because most of the lines we manage are oblique lines. So what's not linear? Well, not linear functions might be something like y equals x squared, where if I graph that, it's going to be some form of a parabola. If I have y equals 1 or something over x, the x is in the denominator. If I graphed that, it would be like a branch here and another branch over here. We get to study all these later, so that's going to be super fun. Here I've got something weird going on. If I graphed that, it's going to start and be like half of a parabola going sideways. If I did an absolute value graph, we're going to study that even in this chapter, I get a V. So those don't form lines, so those are considered not linear. Basically, you need just a plain X, and it needs to be on the top of the function. On top is not one word, but apparently it is on my notes. Okay. So if we go to graph these, this you've done before, and I just want you to kind of slow down and think back to what you used to do. I think of it this way. This is where I start, and then this is how I move. So keeping in mind that it's the y-intercept, so I'm going to start at 7 on the y-axis. So 1, 2, 3, 4, 5, 6, 7 on the y-axis takes care of that. Now, because this is -2, I'm going to go down 2 and then over to the right 3. The top number tells you whether you're going up or down. The bottom tells you going to the right. This is negative, so in this case, from this point, I count down 2 because that's my rise, which in this case is actually going downward, and then over 3. And you go to the right just like you do when you're writing words. So down 2 over 3, down 2 over 3, and then you do the best job that you can to connect those into a line. Now, this one looks kind of funky monkey, but if you change that, because we know that f of x is the same as y equals 3, the only thing that's in my equation is a y. So it's only going to cross the y-axis. So I start thinking, ooh, this is horizontal, which means this 3 tells me where it crosses the y-axis. And I just go ahead and draw that in, which was not a great drawing. There we go. Okay, same thing here. I only have an x. I don't have an xy, and so I think that's kind of different. But if it's only going to cross the x-axis, then I know that's going to be a vertical line, and I count to -1, 2, 3, 4, 5, because I know that tells me which axes it's crossing and where, and then I draw that in. I will tell you that these two things are the most common things that people miss because they're the exceptions to the rule. And so they just forget it. But I'm here to tell you they're the easiest part because there's usually no math or calculating or anything. You just have to remember vertical shows the x because it goes through the x, and this number tells you right where it's going to go through. So easy peasy. Alrighty, so here, this is asking me if this is linear. Well, is it? I don't know. And then it wants me to evaluate this. Now, this notation looks really fancy, but this notation simply means that that's going to be your x. Because remember, it's written as f of x equals y. So it's basically saying when x is -2, what's your y? And how you would do that since the beginning of time is you would plug in your -2. And then that goes back to chapter 1, where we want to be real careful of negatives and powers and all that good stuff we practiced in that first chapter. So first, is it linear? Basically saying, would it form a straight line? And I am going to go with no on the first one because this is going to make it a parabola. I am going with yes on the second because I have a plain x on the top of my function, no like absolute value, square root, squaring, nothing funny going on, no funny business. So is it a function? No for the first one, yes for the second. Evaluating, I can do whether it's a function or not. So here, to get my f of -2, I'm going to be careful. That negative's part of the actual function. Then I'm plugging in a negative because it's asking me to square my x. And since my x is a -2 that I just blabbed all over so you can't see it anymore, then I want to make sure that I plug in a -2. -2, plugging in a -2 plus 7. So be cautious, going back to PEMDAS. Now, you're welcome to use your calculator, but here I would get a 4, but then that would be positive, but there's a negative on the outside. So I'd have -4. These two multiply to become a +4, and then plus 7. So since this is all going to cancel out, because the -4 and a +4, then this ends up being 7 in the end. So I would say f of -2 equals 7, meaning when I put in a -2, I got out a 7 for that one. So then let's take a look at this last one. This is asking for g of -2. So I'm plugging in a -2. Thankfully, I don't have much to do because I don't have much room. Going back to PEMDAS, I end up at -2, which means when I plug in a -2 for the x, I would get out a -2 for the y, and then I could go ahead and plot that onto my graph paper. So this stuff down here is kind of the gist of what we're doing, getting our brains back in line, because no pun intended, the remainder of this chapter really focuses on linear graphs and functions. We are going to be gearing up towards graphing calculator stuff. So if you can get your hands on one, either new or used, or if you want to go to the library and